Hi and welcome to section 11.4. This will be the first of two videos for this section. Section 11.4, we deal with what's known as shifted conics. So what we've been looking at, the parabolas, the ellipse, the hyperbola, those are known as conics. Shifted implies that we're no longer using the origin as our vertex. So I kind of gave you guys a brief preview of this when we were talking about parabolas. And so let's look at it again. So let's recall if we have the following formula. X squared plus y squared is 25. So this is what? This is a circle with radius 5 because of the square root of the 25, and the center is 0, 0, the origin. If we change this equation, let's say x plus 1 squared plus y minus 2 squared equals 25. It's still the equation of a circle. It still has radius of 5. But what changes here? Well, now the center changes because it's shifted. So now the center is -1 and +2. It's the opposite of what we see here. So this exact same idea, what you were doing with just moving the circle, the center of the circle, applies to ellipses and hyperbolas. So it's the same for ellipses or hyperbolas. So for our ellipse, for example, if I have x minus h squared over a squared, an ellipse we have a plus in between here, and y minus k squared over b squared equals 1. So when I now have the equation written like this, the only thing that changes is the numerator. Instead of just x squared, I have x minus h squared. And so here the center now becomes h and k. It's the opposite of what I see. And so how this affects the rest of our information is like the vertices or the foci. We now need to add these values h and k to those dimensions, to those coordinates. So for example, and this could also apply like if the a and b were switched. So this is obviously the equation for a horizontal ellipse. We could also have a vertical ellipse. It's just the a and b would switch, recall. But let's say, for example, I had an ellipse, so i.e., if it's plus or minus a and 0 for the value of where the vertices are. Now, it's going to be plus or minus a plus h, and then 0 plus k. So I need to add that value of h to my a coordinate. I need to add the value of k to my y coordinate. So x coordinate, y coordinate. And that'll give me now the vertices, because when I shift the center, it's going to shift the vertices of this ellipse as well. So same idea for the hyperbola. Whether it's vertical or horizontal, not a big deal. We'll look at the horizontal one here. So it's x minus h squared over a squared minus y minus k squared over b squared equals 1. Again, the only difference with these is whether it's plus or minus. That's our indication. Is it an ellipse or hyperbola? And so again, the center is still shifted to the points h and k. So same idea, to find our vertices, to find the b values for the central box, we're going to need to add h to our x values, k to our y values, depending on whether it's horizontal or vertical. So that's the intro. That's what's happening with the shifted center. How does it affect what the equation looks like? How does it affect where the center ends up now? And then what do we have to do in terms of finding our vertices, our foci, things like that. So that's end of video 1. Come on back, video 2, we'll work a couple examples and see how this all plays out once we have these shifting values.